I'm going to try to cover everything that we need to know for the 10-week assessment that we're about to take. The very first thing is taking small decimal numbers and putting them in scientific notated form and vice versa. And so what we have to remember is that we need our number to be between 1 and 9.99. And so I've got to move my decimal in this number between the 8 and the 2. And what I really want to find out is how many place values we moved it. And how many place values would we have to move this decimal in order to get it back into the original form that it was of 0.00082. And so what I'm going to look at is I'm going to have to move this place value 4 places back to the left if I want to make this decimal work. Let me erase that and try that again. And so moving that back 4 place values to the left, we know that we're going to use a negative exponent. We've got to multiply by 10 to the negative 4th. So these 4 place values that we're moving it ends up being shown in our exponent. All right, now let's take a really large number and do the same thing. 1,200,000. In order to put this in scientific notated form, I need my number to be between 1 and 9.99. So it looks to me I'm going to try to get that decimal between the 1 and the 2. Now, this is a different direction that we're going to move our place values. If I want to turn 1.2 back into 1,200,000, I would have to move the decimal point, it looks to me like 6 place values. And so when I write my number in scientific notated form, these 6 place values get shown in the exponent. So 1.2 times 10 to the 6th is the same thing as 1,200,000. All right, so next thing that is definitely going to be on the test, having a number that has an exponent that's going to either be positive or negative, and knowing the different ways that we can write this number. 4 to the negative 3rd, remember they gave us an integer here in 4, and they gave us an exponent that's negative. So we've got to give them the opposite of that. They gave us an integer and a negative exponent, so that means we're going to give them back a fraction with a positive exponent. And we're going to turn this into a fraction by putting 1 over 4 and putting 4 in the denominator. I'm then going to take my exponent that I have of negative 3 and make it positive 3. Now, 2 other ways we can write this. We can write it as a multiplication problem in the denominator of 4 times 4 times 4. And we can also write it with the answer in the denominator. 4 times 4 is 16. Times 4 more is going to be 64. I'm sure there's going to be also a question on the test, or a couple of questions, comparing scientific notated numbers. How much larger is one scientific notated number than the other? And when we see this, how many times larger one is than the other, we've got to make sure that we understand that we're using division to find out how many times larger something is. Okay, so what we're going to do is we're going to take these 2 scientific notated numbers and divide them. So I'm going to put the larger of the 2, which is 8 times 10 to the 4th, as my numerator, and I'm going to divide it by the smaller of the 2. Now, I know that 8 times 10 to the 4th is larger than 2 times 10 to the 3rd, not by the coefficients of 8 and 2, but by the exponents. 4 is a larger number than 3, giving me more place values in my number. All right, in order to do this, we've got to divide the coefficients, and we then have to subtract the exponents. And what I teach all my students to do is connect the exponents with the operation. So 4 minus 3, and I'm going to write this whole scenario out with the exponents over here of 4 minus 3. Now this is pretty simple. 4 minus 3 is going to give us an exponent of 1. 8 divided by 2 is going to give us 4. And so when we put these pieces back together, we end up with 4 times 10 to the 1st. Well, that's fine, and that's in scientific notated form, but the question is asking how many times larger, and so they probably want this in standard form. 4 times 10 to the 1st just means 4 times 10. And 4 times 10 is 40. So our answer is going to be 40 times larger. Well, I just did a division problem with scientific notated form, so I should cover multiplying scientific notated numbers as well. When we multiply scientific notated numbers, we are going to multiply the coefficients together. So we're going to do 9 times 4, which gives us 36. And we're going to connect the exponents with the operation of addition. And again, I'm going to model that addition problem separately. So I'm going to have -6 plus -3. Now, a lot of kids get confused with this, especially double signs. A positive and negative is a negative. And what I like to say is let's sort these numbers out. Let's sort the socks, as I like to say. Whoops. Let's put all the negatives on one side and all the positives on the other and see what we get. Sort these numbers out. So I have a -6 and I also have a -3. I don't have any positive numbers. So I know that my answer from this is going to give me a negative amount, and when I put those negatives together, I get -9. So taking the pieces that we have, the 36 and the -9, and putting this back together, I'm going to have the, well, it looks like scientific notation of 36 times 10 to the -9th, but it's actually not, because 36 doesn't fall between 1 and 9.99, so I actually have to move the decimal place back one place value. So we've got to go back one place value in order to make this number 3.6. Now, this is where it can get confusing for kids. Since my number of 36 became smaller to 3.6, my exponent now has to become bigger. And in order to make that bigger, I need to make sure that I'm moving toward the right on a number line. So I'm adding 1 to -9 because we moved it one place value. And so what I'm going to end up with is -8. -8 is bigger than -9. If you look at a number line and we put -8 here, -9 here, we understand that the number that's further to the right on a number line is bigger. And as we move further and further to the right on a number line, we're going to have numbers that are bigger. So our answer in scientific notated form is 3.6 times 10 to the -8th. Let's talk about bases that are the same and we have exponents, and we're going to be multiplying and dividing them. In this case, this example, we are dividing 4 to the 6th by 4 to the -3rd. Just like I showed you with scientific notation, when we divide numbers that are in scientific notated form, we're going to go ahead and connect our exponents with a certain operation. And in this particular case, we're going to make sure that we connect them with subtraction, because when you divide base numbers that are the same, that have exponents, you need to subtract those exponents. And so I'm going to connect them, and I'm going to rewrite this whole exponential scenario off to the side. So it's going to be 6 minus -3. We have to know that two negative signs in front of a number is going to make that number positive. And so our answer for our new exponent is going to be 6 plus 3 is 9. And so we're going to keep the base number of 4, and we're going to insert 9 as our new exponent. If we go ahead and we multiply, taking a look at the next example, our bases are the same once again, with 5 to the -4th times 5 to the 2nd. And in this particular case, we're going to connect the exponents just like we did with dividing bases that were the same, but we're going to connect them with a different operation. When we multiply bases that are the same, we need to add the exponents. So I'm going to rewrite this addition problem. And I need to know -4 and +2, what that gives me. Sometimes it helps if we sort those two numbers out into a t-chart or a t-table. 4 is a negative number, so we can put that on the left side, and +2, that's a positive number. We put that on the right. And from here, we know that we have 2 more negatives than we do positives. And so our answer, when combining these numbers together, is going to give us -2. We're going to keep the same base number of 5, and now we have our new exponent, which would be -2. So simplifying this, we get an answer of 5 to the -2nd power. This leads us to solving multi-step equations. We're going to go ahead and we are going to balance this and get it down to a two-step equation, and then hopefully we'll be able to see our answer pretty clearly. On the left side, you can see that we have distributive property. And so what I usually teach is write the multiplication problem out. This is going to be 2 times x and also 2 times negative 3. We need to get those two answers in order to simplify this left side. So 2 times x is 2x, 2 times negative 3 is negative 6. And so I always teach with a pan balance, so I have a 2x on that pan balance and I have a negative 6. Now, on the other side of things, we've got to simplify this in a different way. We've got to combine like terms. And my 7x can be combined with my negative 3x. If we've got to set up a positive and negative t-chart for this to kind of sort it out, negative 3x's and 7 positive x's. I know I've got more positive x's than negative x's, and so that's going to give me positive 4x. I still have this positive 2 here that I can't combine with x's, and so on this side of the equation I'm going to have a 4x and a positive 2. Now, when we take a look at this equation, we always take a look at what can we take off of both sides, and it'll still stay balanced, because right now these two things don't look the same on either side, but they are the same. They mean the same thing. And the first thing I see that I can take off of both sides is I can take off 2x's. So if I take off 2x's on the left side and I take off 2x's on the right side, I'm still left with 2x's on that right side. And so now what I like to do is I like to kind of cover up my 2x and say, what number plus 2 is going to give me negative 6? Well, it's got to be some sort of negative number, doesn't it? If we think about it hard enough, you may be able to come up with negative 8. And then from there, we can get our answer. If we have 2x's, and we realize that those 2x's represent 8 negatives, we can split up the x's, and we'll be allowed to split up our negative 8. And that means that each x is equal to negative 4. So that's one way to solve it. Let me go back and let me erase that scribble and put my 2 back in there. And let's see if we can solve it a little different way. I have 2 positives here, and one of the things that I would do is say that we need to put on the exact same thing to both sides. And in this case, in order to get rid of positive 2, I've got to put on a negative 2. And that's a perfect opposite. It'll cancel it out. If I put that negative 2 on the opposite side, what that's going to give me now is negative 8. And now we're right back to what I did below. My 2x's is equal to negative 8, and I split my x's up, so I split the negative 8 up. So our final answer is going to be x equals negative 4. Let's look at something that will either have no solution or infinite solutions. And again, pay close attention to the variables. If I go ahead and say that we have 2x minus 6 on one side, and the other side is 5 plus 2x. Again, really what you want to look at are those variables. 2x and 2x. What do you notice about them? They're the same. When we have the same amount of variables on both sides, it allows us to take them completely off. And so I can take 2x completely off of the right side if I take 2x completely off of the left side. And now we just have to look at the numbers that are left. I have a negative 6, and I have to ask myself, is that equal to 5? And the answer to that is no, it's not. And so something like this, we would say that there is no solution. So you're going to be able to take variables completely off of both sides, and then you're going to look at the numbers, and those two numbers will not be equal to each other. That's when you're going to get no solution. Last one. Let's see if I can give you one for infinite amount of solutions. I'm going to give you, let's say, negative 8 plus 3x. And 3x minus 8 on the other side. Again, let's look at variables first. First thing I see is that the variables are identical. The other thing that I see is that the numbers are identical. -8 on both sides are identical. And so what we have here is we have two sides that are exactly the same. When two sides of our equation are identical, that means we are going to have an infinite amount of solutions. And if you wanted to, you could take everything off. 3x, if I erase that on one side of my equation, I got to erase the same thing on the other side. If I erase -8 on one side, I've got to erase -8 on the other side. And what this kind of tells us is that everything is equal to everything else. We can use any number that we want, and this equation will always be balanced. We're going to start dealing with proportional linear relationships. And what we have to understand is everybody wants to teach that we're drawing lines and that a linear relationship is a line, and that's true. But really what we're creating and how we create it is we're just building stairs. I always show a video of a do-it-yourself video of somebody making a set of stairs to my students to try to understand how we build a line. And so what I'm going to do, I've got a graph and a table. I'm going to show you exactly how we're going to build a line. I'm going to start off with an equation. It's going to be a proportional relationship, so we are going to start at 0, and we're only going to really deal with the first quadrant. I'm going to give you the equation. Y is equal to 2/3 x. Now, the first thing that I teach all of my students is that we have a numerator and denominator, and of course, the terms that we give it is the rise and the run. But what I really like to dive into with them is making sure they understand that the numerator is going to represent the height of our stair, how tall it's going to be. The denominator, on the other hand, that's going to represent the width of our stair. So right away, we can identify as a class that the width is going to be a little bit bigger than the height of the stair. And now, since this is a proportional relationship, a lot of teachers just say, oh, we start at 0. What I like to do is, since we're kind of now going to construct these stairs, we've got to have a starting place. And since they did not give us a number, usually there's like a +3 here, or there might be a -2. And that tells us where to go on the y-axis. It's called the y-intercept. Well, there's no number there. I like to say, all my rookie builders, we're going to put a +0 to tell us, okay, we're going to start at 0 on the y-axis. So our first point can go at 0, 0, and I'm going to go ahead and label that ordered pair as 0, 0. Now, let's build the stairs. We're going to have a height of 2 and a width of 3. So that means I'm going to, from 0, 0, make the height of my stair, or my riser, 2, and I'm going to then move 3 units to the right, and I'm going to make my next point. Now, what I like to do with a lot of my students is make sure that we label them right away. And what I try to imitate for them is, if this was a giant wall instead of just a graph that's in front of us, and we had to kind of climb up to put this point up where it goes, how would we do it? We wouldn't climb the ladder and then try to move the ladder, hop, 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 to go ahead and put that point there. That doesn't make any sense. We've got to start by moving the ladder to where we want it and then climb up the ladder to put the point. That makes a lot more sense. So what that means is we want to have our x number first, which means this point is going to be 3, and then we climb up it to the 2. So 3, 2. All right, let me move my ladder out of the way, and let's continue to build our stairs. So I'm going to build just a couple more. I'm going to go up 2 and to the right 3, up 2, to the right 3. And we could keep going, but what we've got to understand is that we've created what they call in the do-it-yourself video a stringer. They created this line that's going to support the stairs. We have to draw this. This is probably the most important piece of everything that we're doing, because we've got to support these stairs. Right before, they were just floating in midair. Not going to work. All right, so let's just go ahead. Before we put these into a graph, we've got to figure out what are the other points. And so I'm going to move my ladder to 6. So that'll be the x value. And I would climb up to 4. And let me start back at the origin. I would go ahead and move my ladder to 9. And then I would climb it up to 6. All right, so we've got 4 points. We're going to put these into a table, and I'm going to show you how this table relates to our graph. We always start with the x value first, then the y value. And so the first point that I had was 0, 0. Second point, the x value was 3. We move the ladder and then climb it up to 2, and followed by 6, 4, and 9, 6. Now we could have other points as long as we keep making stairs. And as you see, these stairs are proportional. Each one is the same height, each one is the same width. Okay. How can we tell the height and width of these stairs by the table that we've been given? Well, it's pretty simple. We just have to make sure that we understand that whatever the y value is increasing by, whatever the pattern is, that's going to be our height. And the pattern that we can see here is that it's going from 0 to 2, from 2 to 4, from 4 to 6. It's increasing by 2. So our height of our stairs should be 2. We knew that from the equation. Whoops. Right here. All right, on the other side of things, we have our width. The x value and what that's increasing by or decreasing by determines the width of our stair. From 0 to 3, 3 to 6, 6 to 9. That's increasing by 3 each time. And that's what we used. We were able to see that right here in the equation. And so you have all 3 pieces working together. You have the graph, you have the equation, which is really the directions of how to build our stairs, and then you also have a table. And the table could also serve as directions on how to build our stairs. Hope this helped, and continue to look at my other videos to help you with any of your mathematical needs.